Now let's use a built-in tool in Kali called Uniscan to conduct a vulnerability scan. And in this activity, we're just going to conduct a very simple scan. We're just going to fingerprint the website, and then we'll fingerprint the server. And then in the next activity, we'll do a comprehensive scan that will take quite some time. So in Kali, we're just simply typing Uniscan, and we're just pressing enter to see what the choices are. Now we're going to target Metasploitable, which in my case is 192.168.75.131. So you can see that you can tack H for help, you can tack U, and you really kind of need to do this one. And you can put in either a resolvable name or just an IP address of a URL. So you could say HTTP or HTTPS : some name or : some IP, which is what we're going to do with Metasploitable. If you had a list of URLs, you could have it in a file, each one on their own line, and specify that. If you wanted to, you could leave Uniscan running in the background. And then you could fingerprint the website and then fingerprint the server. We're going to do those. In the next activity, we're going to get really deep and do much more testing, which will take quite some time, but we're going to do a simple one right now. So let's just ping Metasploitable, ping 192.168.75.131. Metasploitable is up. I'm pressing Control-C to break. Okay, so now we're going to, I'm just going to type clear to clear this out, and I'm going to up arrow and just press Uniscan again, so we have the switches handy. So we're going to say Uniscan tack U HTTP : Metasploitable 192.168.75.131, and we'll go after DVWA /DVWA, and then we're going to tack G to fingerprint the website, and let's press enter. And so it comes back and it has done a few tests on this. It did a whois, but let's get to that in just a moment. Let's scroll back. So it went after this thing, and it found out that this is an Apache 2.2.8 on Ubuntu, and of course the IP address we already knew. And then it just did a little bit of looking to see if there were some Drupal modules and web services, and couldn't find, let's see, so the request is, it produced error information. Now this is good to force an error because it will make a site identify itself very often. So it requested just some stuff right here, and that was just to force an error to see if the website would identify itself. So it's not like we had a true error, it was just, it forced it. Just made up some weird stuff and forced the error. And then it was looking for interesting strings. So it saw a label for password and login input, and it saw some other interesting stuff here. These would all be possible areas to pursue if we were tackling this thing. Tried to do a whois lookup, but being a private IP address, it didn't get very far. It got some information out of the American Registry of Internet Numbers, Internet Names and Numbers, but there wasn't a whole lot to be said for it because it's a private address. It's not a public website owned by some organization out there. So with that, that was our real quick fingerprint of the website. Now, if we up arrow, we can fingerprint the server, so we can we don't have to even put in the DVWA here. We're after the server, so it's a tack J, and we want to fingerprint the operating system. We'll press enter and see if it can find out some stuff. So found out the server right away. It was doing a ping. It's trying to do a trace route, doing an NS lookup. The trace route, of course, found it immediately one hop away. It was able to ping. Couldn't find anything in NS lookup, mainly because this is a public IP, a private IP, so it's not going to do anything. It's doing an Nmap, so it's doing looks like a Nmap TAC Cap A scan here. So this will give us a lot of interesting information. If we scroll back here, we can see that it's starting an Nmap. It was loading a bunch of scripts to scan it. Yeah, it looks like a TAC A, Cap A. So it did an ARP scan to discover it, did some SYN scans, some stealth scans. It did some port scans. So this is the Nmap default to look for the 1,000 most popular ports. And we see TCP 21 is open. That implies FTP. 25 implies SMTP. This implies SSH, Telnet, a bunch of others, the RPC endpoint mapper, website, Samba service, possibly a non-standard web ports, not sure yet. Looks like non-standard FTP port and a few other things. And so then it was running some scripts to try to identify the operating system. And so it tried some vulnerability scripts like FTP bounce, so that didn't work. Nothing came out of that. Let's see. It found that TCP 21 is owned by the VSFTPD service, version 2.08 or later. We would do a Google search for vulnerabilities and exploits on this right here. And so that's interesting information. It does allow anonymous FTP logins. That's interesting. And so then it made a connection. And then there's a WSFTP here, or VSFTPD. So we already have that, so there's nothing new there. OpenSSH version 4.7p1. And we could do a little lookup there. It's Linux Telnet D, postfix SMTPD with some SMTP commands. And what else do we have here? There is a bind 9.4.2 DNS server. There's an Apache 2.2.8 web server. And it says it was able to do get, head, post. Let's see, what else do we have? We have the RPC endpoint mapper to various services. We have the NetBIOS Samba services, and this is Samba 3x or 4x, something like that. So we could go after some of the vulnerabilities and exploits for Samba. Let's see, there's a bind shell. Let's see, what else do we have? There's, here it is, that's that Pro FTPD, the non-standard FTP port. What else do we have? We have our login. We have MySQL version 5051A. So there's a lot of possible targets to attack here. And so it goes down and does its best to identify these: Apache JServe, Apache Tomcat, Apache Coyote. And now we can see that it is Linux version 2.6 something, kernel 2.6. So it's either 269 to 2633. Lots of good possibilities to explore if we wanted to further go after this machine here. So yeah, that is the web server and the server scan using Uniscan. In the next activity, we'll get far more comprehensive.